That is so creepy.
No, I'm photographer, I promise.
Why is it cool?
Yeah. Because you're always wrong. You're like, I hear you.
Okay.
I have a video you say.
Need some colors today.
I have a video you say. I hate you. Go ahead.
All right, focus. John, you ready? Here we go. Definition. Starting with perpendicular bisector. If you read each word of the name, it kind of gives away the definition. What does perpendicular mean? More than cross. Cross at a 90-degree angle. Okay, that's perpendicular. How about bisect? What does bisect mean?
Separate into 2 equal parts.
2 equal parts. So a perpendicular bisector is a line perpendicular to a segment at the, if it's going to bisect it, where's it going to be perpendicular at? The midpoint. So that's going to look like this. You'd have a segment, AB, and then if you wanted to draw in the perpendicular bisector, you would first find the midpoint. And that's not a midpoint until I add what to my picture? Tick marks. Now I want a line hitting that point and making a right angle with the segment. So that would look like this. And what do I have to add to make sure that that's a right angle? The little square thing. If that's not there, you're not perpendicular. So this line L is the perpendicular bisector for segment AB because it's hitting the midpoint and it's making a right angle with AB. Okay, we're going to come back. We're not going to construct the perpendicular bisector, but it's going to be our example down here. So we'll skip by that. Now we're going to find the shortest distance to a line from a point not on the line. So pick a point P up here in space. Then I want you to randomly pick 3 points on this line down here. One really close to the arrowhead, one a little bit over, and then one way over by the other arrowhead. If you still have your 6-inch ruler and it's handy, take that out. If you don't, just write down the numbers I give you. We're going to measure from each of those points to P. So I'll go draw in the line and put in its length. I'm going to use millimeters for my length. So that's about 44. Then the next one, draw the segment in and find its length. Millimeters? Centimeters? I don't care. Use whatever you want. 35. And then this one's about 37. Okay, everybody got their 3 measurements?
No.
Not yet. Not yet. Okay. Now has everybody got their 3 measurements? What did you do? Wait till I was all done? No? What?
Let's see.
Okay, I can't wait any longer. That was only 3 segments. Okay, find your shortest one. Do you think there's a point on this line down here that's going to be closer to P than your shortest one?
No. Yeah.
Yes.
How about on mine? Where would that point be at, do you think?
The middle of B and C.
Why the middle of B? Just always have to be the middle of, what if I had put C way over here?
Well, then it would be more towards B than this.
So I need a better spot than the middle of B and C.
I'll go left.
Rodney?
The midpoint of A and C.
Maybe not. Maybe not.
I already said that.
Reese?
The midpoint of the line.
No, it has nothing to do with midpoint. Rodney?
Depends where P is at.
The middle left of B and C.
Depends where P is at. P could be.
Okay, let me try another picture. Don't write. I'll give that. Where's going to be the shortest distance to that line?
Straight down.
Middle.
Straight down.
Where it's perpendicular.
Oh, where it's perpendicular. That's a difference. If I made a right angle, would that be the shortest distance to the line? If I get off of perpendicular, does that make it longer than that one? Yes, it does. That would be the hypotenuse of this right triangle. So, do I have the shortest distance to point P when I'm standing at B? No, because you can kind of eyeball, like, I could do better. This is not a 90-degree angle, right? Did you guys put in a 90-degree angle on yours? No. So, what we want to do is just eyeball it with your ruler. Make a right angle from P down to that line. Make a right angle, measure it. It should be shorter than your shortest segment you've already got right now. And mine is about 34. So the whole point of this little measuring was to find the shortest distance to a line is the perpendicular distance. So if you want the shortest path
Sorry for the interruption. JV volleyball at Rapid River tonight is canceled. JV volleyball at Rapid is canceled. Also, JV football players, you will be doing the equipment drop off not this Monday, not today, but next Monday. Thank you.
Okay, example 3. We're going to bring it up here to this space where we didn't do the construction. I'm going to give you a point P. I'm going to pick A over here. And C is going to be right below it, making a right angle. So, there's your picture. So we've got two segments, PA, PC, and then our line along the bottom. And what this example is telling me is that the length of PA is x minus 8. And the length of PC is 12. And this is asking us to write an inequality and solve. What's an inequality? Yeah, greater than or less than sign in it. So, these are two lengths. How do they compare with each other? Based off of what we just learned about the shortest distance. Reese?
X minus 8 is greater than 12.
Do we agree that this length of x minus 8 is greater than 12? Because 12 is the shortest? There's our inequality. X minus 8 is greater than 12. Because 12 is the shortest distance to the line. How do we solve an inequality? Just like it was an equal sign, except for one special case. So if I'm going to get x by itself, we're going to add 8 to both sides. So that means we're going to be left with x. Does that change the sign here, adding 8 to both sides? What does flip the sign? Of a negative. You multiply or divide by a negative, you got to flip the sign in the middle. Do you remember that from Algebra 1? Multiply or divide by a negative flips the sign. That didn't happen in this case. Adding and subtracting doesn't change it, so we keep it the same. So what do we got? 20? X is greater than 20 is our solution. Okay. We have 3 theorems today. And instead of making on the homework, they'll refer back to them. You're allowed to call them Theorem 1, Theorem 2, and Theorem 3, even though they don't have any special names to them. So they're kind of common sense. So it says, if 2 intersecting lines form a linear pair of congruent angles, then the lines are, so there's going to be a relationship there. So let's draw a picture of this. So we've got a line, and then a second line intersecting. Well, that didn't come through very good. Let me get this thing working here. But it says this linear pair of angles are congruent to each other. Well, if those are congruent, what do you know they're going to be?
I don't know, right? Well, 90 degree.
Do you agree both of them have to be 90? Because they have to add up to 180. And if they're both going to be equal, they both have to be 90. If these are 90-degree angles, what would you say is the relationship between the 2 lines? They are perpendicular. So, if those are congruent, then we know, we just kind of did a little mini proof there when I talked through it, those are perpendicular, 90 degrees. So finishing off the proof, if the linear pair of angles are congruent, then the 2 lines are perpendicular to each other. All right, theorem 2. In a plane, if a transversal is perpendicular to one of 2 parallel lines, so let's draw a picture of that and see if you can tell me the relationship. So we've got 2 parallel lines. A and B, we'll call them. We've got a transversal. Remember, transversal intersects both of them. It's perpendicular to this first line. What is the red line's relationship to line B? Do you agree that that also has to be perpendicular? There's no other option there? Because if the lines are parallel, the corresponding angles have to be congruent. So this would be a 90 also, making them perpendicular. So that does finish off our theorem. If a transversal is perpendicular to one of 2 parallel lines, then it is perpendicular to the other line. So they don't have to tell us, we can see it. So if it's perpendicular to the first, then it has to be perpendicular to the second. Good? All right, theorem 3. If 2 coplanar lines are perpendicular to the same line, then the 2 lines are. So we'll be looking for the relationship between the first 2 lines. So we've got a line. Now I want 2 lines perpendicular to that line. So So here's line A. It's perpendicular to that red line. Now I've got a second line also perpendicular to that red line. It's asking for the relationship between the two lines A and B. Do you agree that A and B would have to run parallel? Good? Not good. Okay, we got a proof coming on 2. So, given line R is parallel to line S, and angle 1 is congruent to angle 2, can you prove that line R is perpendicular to line T? And here is the picture. There's R. Here is S. Here's T. 1, 2, 3. Okay, so starting off, we've got R parallel to S. I'm going to put those markings in. And then we're also 1's congruent to 2, given. Our goal is to get R perpendicular to T. Here we go. You should, again, be able to fill in the parts I leave out. So R parallel to S, given. Okay, I'm going to logically connect something to this fact. Because I know R is parallel to S, I am allowed to say that angle 2 is congruent to angle 3. So take a look at the picture. Why would I be able to say 2 and 3 are congruent? What kind of angles? CAC. If the lines are parallel, that was our first day, then corresponding angles are congruent. We know that. This is CAC. So, angle 1 is congruent to angle 2. Not logically connected to anything. It is in the given. It is. Oh, I forgot to mark. 2 is congruent to 3. Okay, I want you to logically connect these two boxes and tell me what should be in here. That's one I think you should be able to put together. Isabel? Why? Yes. Angle 1 is congruent to angle 3. Take a look at the boxes to make sure you understand that. See how 3 is congruent to 2 and 1 is congruent to 2? Anytime they're congruent to the same angle, they're congruent to each other. You can do transitive property or substitution. But that's transitive or substitution. So you can see I've got these two angles being congruent Does that make R perpendicular to T? Which theorem says so? It's one of our 3 theorems from today.
Theorem 1.
Theorem 1?
Yep.
He is correct. Take a look at it. If you've got those 2 angles congruent, which we have, then the lines are perpendicular by theorem 1. So our reason, you don't have to write out the theorem, you just get to put theorem 1. Okay, and then you're going to have some algebra problems today. So we're going to do a big algebra one down here with the system of equations.
What is the system of equations again?
I'll show you. These 2 lines, this, and, oh, let's see, can I get a 90? Let's see. I think so. This. Before I start filling in X's and Y's and everything, because these 2 right angles are here, what's the relationship between lines A and B that they're not telling me that I know is true? They're parallel. So these are parallel lines. They're not going to tell you that. You're supposed to know that. Now, this angle over here is 2y degrees. This one is x degrees. And the one next to it is x plus y degrees. Your goal is to find values for x and y, which means you're going to have to write a system of equations. Just take a look at positioning or anything. We got to come up with 2 different equations. So take a look. Who sees anything that's true about pair them up 2 at a time? Reese, what do you see?
2 y would have to equal x because they're corresponding angles.
These are not corresponding. Corresponding means you slide them over and they overlap. Anybody see anything else? Isabel?
2y should equal x plus y because they're not alternate exteriors.
How about alternate exteriors? So if you ignore that, these are your parallel lines. Those are alternate exteriors. So one equation is going to be x plus y has to equal 2y because those are alternate exterior angles that are congruent. Okay, one equation. Now we need a second equation. What about x? No, but there is something special for those 2. What are they? Has nothing to do with parallel. Reese?
They're supplementary
Why are they supplementary?
because they're on the same line and equal.
Linear pair. They are a linear pair. Remember the adjacent ones that make a straight line? Do you agree that these 2 have to add up to 180?
Yes.
Yeah, I didn't have to go over there. So x plus y has to equal 180. Anything you can see from the whole year that you can write 2 different equations is your goal here. You're going to see when you get to the homework, there's going to be like 8 different equations you could use. You only need 2. Come up with 2. This is linear pair.
Do you need that ending?
No, I'm just so if you look back, you'll know where they came from. You don't have to justify why you're writing them. Okay, I'm going to simplify this one. So the x plus y can simplify to 2x plus y equals 180. Okay, we solved systems last week. So I need x and y on one side and then the constant on the other side. So this equation, I want to bring this 2y over here and combine it with this y. So I'm going to subtract 2y from both sides. And then I'm going to rewrite it down here. What's this equation going to be after I subtract 2y from both sides? X minus y equals, my equal sign is still here. What's left over here? 0. Don't be afraid to write down a 0. Everybody likes to hate on 0. You know what I see people do? They go back and they stick the equal sign between the x and y, like, I got to have something on each side. Well, 0 is something. Put down a 0. All right, now we're looking at these two equations. Are they set up to add together right now? Got lucky on this one. We don't have to do any extra work. So we combine. We'll have 3x. The y's cancel out. Equals 180. Divide by 3. X equals 60. And now you can go back anywhere you like with this x. I kind of like this one. I think this one's the easiest. X minus y has to equal 0. Well, if x is a 60, what's y going to be? Also 60. 60 minus 60 gives you 0. So you got a whole chunk of problems where you got to find two equations based on where everything's at. Okay, page 175. 6 through 34 with a bunch of skips. Skip. 15, 23, 25, 26, 29, and 30. No,